to each other. Now we're going to look at the units. So the change in momentum still uses the same units as momentum, which is kilograms times meters per second. Time is in seconds and force is in newtons. So how do we get from newtons times seconds to kilograms times meters per second? Well, a newton is equal to a kilogram times meters per second squared. Now, if we multiply a newton times 1 second, that's going to be the same as saying a kilogram times meters per second squared times 1 second. Now, this second is in the numerator. These 2 seconds are in the denominator. So I can actually cancel out one from the numerator with one of the ones from the denominator. So I end up with kilograms times meters per second. So that's how that works. All right. So now let's go ahead and try to rearrange this equation algebraically to solve for each variable. So if I was trying to solve for delta P, or the impulse, the change in momentum, I actually wouldn't need to change this equation at all because delta P is already by itself. Okay? Now let's say I want to solve for the force that the object experiences. If I want to get force by itself, I have to remove everything else away from force. So that means delta T needs to be removed. Now currently, force and delta T are being multiplied. So in order to separate them, I need to do the opposite of multiplication, which is division. So I'm going to divide by delta T on both sides. That cancels numerator and denominator. So I end up with delta P, momentum, over delta T, or impulse divided by delta T, equals force. Okay? And my units will be in newtons. This will be kilograms times meters per second divided by seconds. That second, if we use the keep change flip rule, it's going to be kilograms times meters over second divided by seconds. Keep change flip rule says I keep this, I change my sign from division to multiplication, and then I flip my units. So instead of seconds, it'll be 1 over s. All right? Now when I multiply across, I'll end up with kilograms times meters up top times 1. Because it's times 1, I'm not going to write it because anything times 1 is itself. And then I have seconds in the denominator and seconds in the denominator. So I end up with kilogram times meters per second squared, which is indeed 1 newton. All right? So that's where that comes from. Now let's go ahead and solve for delta T. All right, so I've got delta P equals F times delta T. If I want to get delta T by itself, I need to get everything else away from delta T, which includes getting F away from delta T. Right now, both of these are being multiplied, so I'm going to divide them to separate them. I divide by F to get F away, all right, on both sides. So impulse divided by F equals delta T. Now let's see how those units work out. So that is kilograms times meters per second divided by newtons. Okay. Now we already said a newton is equal to a kilogram times meters per second squared. So we're going to go ahead and do this in our keep change flip rule. So kilogram times meter over seconds divided by kilogram times meter over second squared. So keep change flip rule says change the sign, keep the first, change the sign from division to multiplication, and flip the second. So that'll be second squared over kilogram times meters. Okay? So my meters in the numerator cancels with meters in the denominator. Kilograms in the numerator cancels with kilograms in the denominator. And now I've got 2 seconds up here, and I've got 1 second down here. So that 1 second cancels with one of the seconds up here. So I'm left with seconds in the numerator, all right, which is the unit of time. All right, so now we see how that works.